Hello, I'm here today to talk to you about electrostatics, aka static electricity. My voice is a little rough, so I'm going to apologize for these next set of videos if you have a hard time understanding me or if I just sound funny. Electrostatics or static electricity is about electric charges that do not flow, aka not electric current. So not the stuff that you found in an outlet, but more like the kind of charge that you get when you like scuffle your feet together in the middle of winter and you touch something and you get a shock. So they're basically considered electric charges that do not move or do not flow, but the reality is that they can move a little bit, they just don't move continually. And when we talk about charge, there's a unit we use for it called coulombs. It goes by the letter C, it's a scalar quantity. And charge itself goes by the letter Q. Sometimes you'll see an uppercase Q too. So Q represents the charge of an object. Now you're probably familiar with some of this already, like protons, electrons, and neutrons. And so we know that protons have a positive charge. I'm just going to put a positive there. We know that electrons have a negative charge. And we know that neutrons have zero charge. Now we can actually quantify the size of this charge, and we do this by defining the elementary charge E. And E, if you look on the physics reference table, page 1, has a value of 1.6 times 10 to the negative 19th coulombs. So this value is what represents the variable E. E is 1.6 times 10 to the negative 19th. And you'll see this number crop up in a couple different places. But what we find is that if you measure the actual charge of one proton and one electron, and you can say one neutron as well, one neutron has a charge of 0, we know that, but one proton has a charge of plus E, and one electron has a charge of negative E. So they have exactly the same charge, except one is considered positive and one is considered negative. Now the positive and the negative are a little bit arbitrary in the way that they were defined, but they do cancel each other out, so it's important. I mean, it relates to the spin of electrons and that sort of thing. It's important to just realize that they are opposite. So that would mean that a proton, which has a charge of plus E, really has a charge of 1.6 times 10 to the negative 19th coulombs, and an electron, which has a charge of negative E, has a charge of negative 1.6 times 10 to negative 19th coulombs. And a neutron, which has a charge of 0 E, has a charge of 0 coulombs. And so you can combine protons and electrons and neutrons and see what they get. So for example, if you have like 2 protons, 4 electrons, and it doesn't matter how many neutrons, let's just say 7 neutrons. The total charge of 2 protons is 2e, 4 electrons is negative 4e, 7 neutrons is 0. You can add them all up together and you get a net charge of 2e minus 4e plus 0, so a total of negative 2e, which is going to be equal to negative 2 times the elementary charge, or negative 3.2 times 10 to the negative 19th coulombs. So it's really easy to add these together, and you will see the E used, or you will see it done in coulombs as well. So let's talk a little bit about how charge flows. And so I want to differentiate between what are considered conductors and insulators. I'm going to erase this part here. So a conductor is something, a material where charge flows easily. And when I mean charge, typically what we're talking about is electrons move easily. Because even in most conductors, protons stay still. Protons are kind of locked into the lattice of the material, the molecular structure. But if you think back to chemistry, for example, you know that electrons can be easily gained and lost by atoms, and so some materials, they're very easily gained and lost, so they can bounce around through a material, and so a conductor is where those electrons can move freely through the material. An insulator is where charges, both positive and negative, don't move easily. So let's say we have two materials, a conductor and an insulator here. And if you remember, like charges will repel each other, meaning two positives will repel each other, two negatives will repel each other, but opposite charges attract. So a positive and a negative will attract each other. And so let's say we bring a object that is negatively charged near both of these objects. In the conductor, what we find is that the charges move around pretty easily, and so the charges that are attracted to this, being the positive charges, well, they don't really move, but the electrons do. So what you end up getting is the electrons will move away from this, and that leaves not necessarily more positive charges, but it makes this side more positively charged because the electrons left. I don't know if you can read that. I said electrons left. So because the electrons left, that leaves a very positively charged side and a negatively charged side. So you're basically inducing a charge difference. That's what you get in a conductor. The electrons move around pretty easily. They leave gaps here, so this is positively charged, and you get a surplus of electrons over here, so that's negatively charged. The electrons are repelled by the electrons in the rod. And an insulator, on the other hand, when you bring them close together, nothing happens because these charges cannot move. So protons stay still and electrons stay still. So most of the materials that we're going to be talking about in this particular class are going to be conductors, but we will occasionally touch on insulators. But if you're really looking for static electricity, it becomes more interesting when you deal with conductors, because that's how charges actually move around and flow. I think that about does it for this particular video. If you've got any questions, make sure you write them down, and thank you very much for watching.